And now we are going to look at arrays from the memory point of view. We will be just be covering the basics. We won't go too much into the depth of it. We will be just understanding what we need to understand, and through this minimal example you would be able to fully grasp the concept of arrays without going too much into the memory and stuff. So the basic idea of how arrays work in the memory is that when you make variables, the variables are scattered anywhere in the memory. So you cannot like print them out all at once, or you cannot take input from them all at once. The sense that we get that we are able to take input at once or print the variables all by once is because the variables of the arrays are stored one after another in the memory. No element, no other variable is stored between them. So for instance, if I had variables like int variable 1, int variable 2, and if I define these variables, they would be stored scattered anywhere in memory. So there is no guarantee that they would be like one after the other. But whenever there is an array, in an array the variables are always one after the other. So the proof of this, we can see this using the ampersand operator. So let me define this array of 3 variables 1 2 3, and let's print out the addresses of these arrays of these 3 variables in the memory. So we would do this like we could do it in a for loop, or we could do it without for loop, but we should do it in the for loop as it's convenient. I++ and cout ampersand variable with an I, and now I'm going to do an endl. So there is a new line, so we can distinguish between the addresses. So now let's take a look at our output. So here we can see we have like 3 variables here, and there are 3 complex addresses. We do not need to understand the addresses. The chances are it would be different for you as you tried it. We are not supposed to understand that, but we are just supposed to take a look at the last 2 numbers or the last 2 hexadecimal digits of the addresses. Here we can see we have a C here, and we have a 0 and a 4. So what is actually happening here is that an integer variable takes 4 bytes in the memory. Integer takes 4 bytes in the memory. So the 8C is the hexadecimal number, and the 90 is also, and the 94 is also the hexadecimal representation of the number. So if we look at the calculator, we would see that they have a 4 digits gap between them. So we could say 8C, and let's convert it into decimal. So we have a 140. All right, and now let's see what is a 90 in the decimal. So we have a 144. Similarly, a 94 in decimal would be 148. So we can see this array and the 3 variables inside it are taking contiguous memory allocation, contiguous memory spaces. So this is why all the simplification, all the convenience we get in array is possible, because they are taking contiguous memory allocations. In simple variables, the variables are pretty much scattered in anywhere in the memories. There isn't a guarantee. This is why the variables are not accessible like an array is accessible.